video right now, every word you hear, every pixel you see, it's just ones and zeros. Crazy, right? But how does that even work? And that's exactly what I'm going to decode in this video. So, hey, I'm Hardik, I'm an AI developer, and this is episode 1 in the series Let's Build a Computer from Scratch. And today in this video, we are going to uncover how binary, the language of computers, actually work in the real life. Alright, so let's get right into the computer and understand how binary actually works. Okay, so think of numbers like a light switch. In a light switch, we have two modes basically, on and off, right? And in computers, that's exactly how computers understand. 1 is on and 0 is off. Okay. Now, in decimal number system, we used to actually have 10 different symbols from 0 to 9, right? Which, based on which we used to actually, signify different numbers on our number system. But in case of binary, we just use these two symbols, 1 and 0, to represent different numbers that a computer actually understands. You and I can actually converse in English, but a computer doesn't understand English. It just understands ones and zeros, because at the core level, computer is just millions of tiny switches that's constantly flipping 1 and 0 in just a very fast manner. So fast, slow blazingly fast, that we also can't understand that what process is actually going at what speed, right? So this is what a basic introduction of binary will look like. It's all just ones and zeros. Okay, now how does this ones and zeros actually make sense? Before even knowing that, we actually need to understand what even is a bit. In computers, we actually operate on bits. Now what is a bit? A bit is just one symbol, either it's 1, either it's a 0. And when we combine this bit, like 8 bits, now when we combine these 8 symbols into a series, it's called a byte. Like a byte is just like, you can think of it like we can have 8 symbols of zeros and ones, which in turn actually means that we have actually 8 bits on our system, and we can read it thoroughly, and that's what a byte is. Now, how do we even read binary? Let's take example of this number 332. All right. Now, just as we do ones, tens, 100,000, 10,000 in English, we do something similar in binary as well. Like, we take the base as 2 because we have only 2 symbols in binary number system, and then we assign the place value starting from 0, right? So it goes all the way from 0 till 8. Like, we don't take up till 8. We have just taken this, I've just taken this example to be just in a sure zone that, okay, this number doesn't exist up till something which we can't even denote on binary. Okay, so what we do is, like, 2 to the power 0 is 0. Okay, 2 to the power 1 is 2, and this all the way goes up to 256. You might have seen this pattern something in computer systems, like it's all just multiples of 4, powers of 4, 2, 4, 8, 16, 32, 64, 120, and 256. Now, these are the different numbers that can be denoted using this power of binary, right? And now we actually need to do an operation, like we need to find a particular pattern for these numbers to actually add and subtract them to make up this number. Now you can actually see this, like wherever we want that number, we'll actually denote that with 1, like this particular bit, 2 to the power 8 is actually on at this moment, and 2 to the power 7 is off at this moment. So this number which we have, which you can see on the screen, is 101001100, which comes back to 256, and 128 into 0 is 0. 64 is on, so we take 64. 32 is off, so we don't take that. 32, 16 is also off. 8 is on, we take that. 4 is on, we also take that. 2 is off, and again 0 is off as well. So we take this as 256 plus 64 plus 8 plus 4, which comes back to 332. And that's how we actually represent any number in binary. Think of maybe let's say 10. Okay, we actually had to denote the number 10 from decimal to binary. How does that computer understand 10 in binary? We could have taken something like 8 and 2, and the rest of these would be turned off. So the number could have been 1010. So that's 10 in binary, right? Why do we need binary code? Like, some of you might say me that, Hardik, we were quite confident with decimal number system. will be the need of this binary code? Like, what is the need of understanding a new number system out of the blue? Well, my answer to that would be that the computers that we actually see on the screen, right, and at the core, it's a little different. Like, there's a term called abstraction in the real world where you actually hide the underlying things and just show the important things to a user. So the user doesn't need to understand what actually is going on the inside. But on the inside, computers is nothing but just made up of small chips or switches that I have been talking about from my previous video, which is just known as transistors. Now these transistors are nothing just electrical appliances which can only denote one state at a time, like one value at a time, which is either on or off, because those are just switches. It's not a LED screen which can show you numbers on that, right? So scientists in the previous days, in the older days actually, found out a way to actually use these symbols like the ones and zeros, the on and off states, to actually denote a whole number system in its own, and that gave the birth to binary. Well, everything that you see on YouTube, like maybe on YouTube, on Instagram, on social media, or even your gallery, everything is made up of binary, of pixels, text, images, sound, videos, everything is converted into binary before it is processed into our computers. So binary is truly the language of computers, right? Now, I have already had a discussion about this, like what is a byte and what is a bit. As you all know, like bit is the smallest unit which can only denote one state at a time. Either it's on, either it's off, right? And byte is like a string of 8 bits, like a continuous memory allocation where we have 8 bits in a row. Like just now we saw an example of 8 bits. Like you can see here, this is 101001110. Well, we have over 9 bits over here, but yeah, if we could have taken only 8 bit outs of it, it could have been a total of byte. It could actually represent a byte in total, right? And yeah, these are some popular numbers, like from decimal to binary. 0 is 000, 1 is 0001, 2 00010, and up till 10, which is 1010, and henceforth. Like I just showed you the whole conversion, how you can actually start thinking in binary. Well, right? And yeah, some binary facts. Okay, ancient Egyptians discovered binary code. Like binary is actually very old language. A byte is a collection of 8 binary digits. We already know that. Binary code is the basis for all computer languages. We actually also know that as well. If the last digit of a binary number is 1, it will be odd, and if it is 0, it will be even. Like quite common, because everything divisible by 2 actually has its last digit as 0 or 4 or something like that, right? And if it's 1, like it's odd, right? That's a very simple fact. So yeah, like this was all about binary, and in the next video we'll actually understand where do this binary actually get compiled in the real physical world of a computer. And up next we have logic gates in the next video. So yeah, stay tuned. By then we'll explore that in episode 2. Thank you for watching this video. Bye bye.